Okay, and so the fuel type is also significant. Now we can combine all of this into summarized ANOVA table. Okay, so residual is exactly the same as here, so there is no change there. So we can just copy it straight down from there. Well, we will set up the mean square ourselves. So sum of squares we'll get from this table. Okay. The model is the sum of all the variables, okay, in the model. So that's what model means. So from this ANOVA table, you sum all the degrees of freedom of the predictor variables, okay, and sum all the sum of squares of predictor variables. So that will be your model degrees of freedom and model sum of squares. All right. Then, okay, we take the sum of squares and divide by the degrees of freedom. Sum of squares divided by degrees of freedom will give you the mean square. Okay. Now F is, okay, so by the way, so this is called MSR, mean square regression. So that's what that is. So this is called mean square regression. Okay. And this one is called what? MSE, mean square error. Now F is equal to MSR divided by MSE. So that's what F is. So we go MSR divided by MSE. So that's our F for the entire model. This is not individual of anything, it's for the entire model. And then this is the p-value, and we use the function called f dist RT. So that is of this form. Okay. So that's the formula. So if you go f dot dist dot RT, okay, the first item is the f value. Okay. And then we have to provide 2 degrees of freedoms for the f value, and that is, we have f is MSR divided by MSE. So what is the degrees of freedom for MSR? That's your first degrees of freedom. Okay, what's the degrees of freedom for the denominator, MSE? That's the second one. Okay, so here the first one is that cell, and the second one is this cell. And this is our p-value. This is for the entire model. Okay. Again, same deal. Okay. It says probability. This gives you the probability that the model is no good. Okay. So the model is not doing anything for us. And as long as that probability is less than 5%, we are good. Okay. So So this says it is 1.08 times 10 to the power of minus 168. So it's extremely negligible probability. So our conclusion is the model is significant. So we'll come to that in just a second. Okay. So here we have MSE. Okay, so MSE is that, right? Now, RMSE, that is root mean square error. Root mean square error is the square root of MSE.